그냥 나갈 때 కింద రావచ్చు ఇదే లోపల ఏం చేస్తున్నా లేదా రానా చూడు మేడం తీసుకురా సిస్టమ్ తీసుకురా మేడం పాస్వర్డ్ చెప్పరా
యువసరి చెప్తున్నాడు అది కూడా పొద్దున్నే Let's write one design of differentiator and integrator using APA. I'm not sure, but what is this? What they're asking here? ఐకాన్ మీద
ఎక్కడ మేడం ఎక్కడ ఐకాన్ ఎక్కడ ఉంది
మీరు ఇక్కడ పార్టిసిపెంట్స్ దగ్గర రావట్లే మళ్ళీ ఇదే మాట్లాడుతుంది
Great, sir.
Hello, sir.
Yeah. Good
I will
afternoon,
come
Sachin, sir.
Yeah. Hi, sir. I will just come in 2 minutes, okay?
Yeah,
Good.
sir. Right, sir. Right, sir. Right, sir. Right, sir. Sir,
Let all the participants are informed that the test will be joined, resource person will be joined within 2 minutes.
So should we start, sir? I'm back.
yeah, right, sir. Good afternoon, Sachin, sir. Thank you so much for accepting our request and coming to join here and deliver your today FDP on IoT and embedded system. I request Sachin sir, please read the Sachin sir profile and continue the session.
Right. Thank you, Amrita Saiga, sir. Good afternoon, one and all. Today's our resource person is Dr. Sachin Chaudhary, Associate Professor and Signal Processing and Communications Research Center and Smart City Research Center, ECE Coordinator at International Institute of Information Technology, Hyderabad. Dr. Sachin Chaudhary has received a Bachelor's in Electronics from Visvesvaraya Institute, National Institute of Technology, Nagpur in the year 2002 and Master's in Engineering Telecommunications from Indian Institute of Science, IISc Bangalore in the year 2004. At IISc, Dr. Sachin Chaudhary with the Professor K.S. Hall during 2004 to 2007 the Bangalore Startup Park IISC professor as a senior wireless communication engineer and has worked as a development and implementation of wireless systems such as wireless LAN, WiMAX, and HDD during 2007 to 2012. PhD professor at the Department of Signal Processing and done novel work in the Center for Excellence in Research nominated by Academy of Finland. So, 2011 and at the done postdoctoral research at Aalto University. In December 2014, Sir has joined at IIT Hyderabad as assistant professor, and Sir has now as promoted as associate professor in the July 2021. And Dr. Sachin Chowdhury is a senior IEEE member and representative of IIT Hyderabad to Telecommunication Standard Development Society of India. I'm very glad to have you, sir, Sachin sir. Sir, I invite you to start the session, sir.
Thank you very much for the introduction, and thank you very much for inviting me for this talk. So, my talk is titled as Internet of Things, Introduction, Application, and Research Activities. So, just to highlight that I have been working a lot on last 6 years, I've been working a lot on IoT related topics, and I will be talking about some of them now also. So I will start with today's, talk with a basic introduction to Internet of Things and what is the motivation for that and what are the applications of IoT, some of the applications. And then I will talk about some of the research activities I'm doing at IIIT. Am I audible? Just to check, is my audio clear?
Yes, sir. Clear, sir.
Thank you, thank you. So then let's, if you now look at the definition of Internet of Things. So if you now try to search for IoT, what is the definition of IoT? There are, I think, some participants like unmuted. I will request them if they can mute themselves.
Dear participants,
Shinde, P. Shirisha. Yeah, thank you. Yeah. So when you want to understand what about any new technology or new topic, what do you generally do? You generally go to the Google and then try to search about it, right? Nowadays you do ChatGPT. Especially if you do Google search, then you will get, let's say, millions of definitions like this or hundreds of definitions like this, which are right, but they are very complicated to understand. So generally what I prefer is that if we try to understand what is IoT based on our understanding of internet, right? We all have been using internet since last 20-25 years. So all of us understand internet very well. So if we start from our definition there and then extend it to the add it to the things perspective, then we will get the Internet of Things definition. So what is internet? Internet is basically a network of computing devices. What are computing devices? So you have things like computers, servers, smartphones, tablets, right? So all different this kind of devices which have a lot of computing power, lot of memory, then a lot of power. So now the network of such devices is called internet. And now if I add the things of daily use, such as bulb, then there's a plant here, a fan here, right? Then and dustbin here. So basically then that will become Internet of Things. So why do we need a slightly different definition is because there's a distinction between computers and IoT devices, right? So what is computer? Computer is a general purpose machine. It's a computing, its task. What is its task? Its task is computing. And so it can be anything. The computation is a very general purpose task. It can be anything. It can be running a program. It can be watching a video. It can be attending a class. it can be writing a document, right? Listening to music. And so it has multi-purpose, right? That's the reason I'm saying it is general purpose. So the main task is computing, and like which can be generalized to any task. And these devices have significant resources, memory, power, speed, right? And they're expensive. And take an example like iPad, iPhone, and everything, right? On the other hand, if you see, the question is, what is the task of a washing machine, right? So for washing machine, there's only one task of washing the clothes, right? There's nothing else. So the main task is here is not computing. It's only that one specific one or two things which we want a device to do. So that is the reason we want it to be very cheap. If I would not want, as a customer, I would not want a device like washing machine to be connected to internet if it's costing me, if I have to connect a iPhone to the washing machine, right? So otherwise, what will happen is that the cost of the solution will be much, much higher as compared to the normal washing machine, right? The same washing machine which I was buying normally, like maybe 30,000, 35,000, that will cost me another easily 60,000, 70,000 because I'm adding a premium computer or iPhone to connect it to the internet. So the idea is the cost of the device which will connect washing machine to the internet should be 1/10 of the washing machine. Okay, then only maybe it will be people will be willing to buy. If it's so, that is the reason it has to be cheaper, efficient, and faster for that one particular thing. Okay, so I will switch off the video. It's showing some internet issues. So the main task here is basically not computing, and that's the reason basically I'm saying, because it has to be cheaper, it will have limited resources, right? It will have a limited amount of memory. It will be, instead of a whole computer, it will be a microcontroller, and then you will have a very limited power, especially for the battery operated devices. Okay, so that's the difference between the IoT devices and computers. So how do you connect a thing to the internet is basically, let's say I want to now connect this shoes to the internet. So for that, I need to embed a electronic device as something similar to this inside the shoes. So it should at least have sensor or actuator, which is kind of overlooking or observing some physical phenomenon related to the shoes. Okay. So it can be a pressure sensor. Then there has to be a microcontroller, which will be basically sensing, doing computation, and it will all, and then you need a connection module to connect it to the internet. And obviously you need energy for doing any task. So a battery is needed. So this is how the Internet of Things works. So you basically you have sensors here which are monitoring some physical phenomenon, and it is connected to the gateway, and the gateway is connected to the internet. So the data is sent. We are sending data through the sensors to the internet. We are storing it somewhere. We are analyzing it somewhere, and based on the analysis, we can send some actuation command. Okay, to the IoT device. So one example is that take an example of air monitoring device inside our house. Okay, so assume that we have air monitoring device inside our house. We are living in Delhi. It's pretty polluted most of the time, and we also have an air purifier. So what will happen is that the air, let's say, monitor will send data to the internet. From the internet, we can pick up what is the how much is the pollution outside the house, and if there is a lot of pollution inside the house and outside it is pretty nice, then you will open the window, right? And and then you will switch off the air purifier. But on the other hand, uh, let's say the air pollution is very high outside, then you will shut the window and switch on the air purifier inside. Okay, and this can be done completely in an automated way while interacting with the internet. So this is one of the most important slides of my presentation. So basically, at this point, I want you to answer. Okay, so maybe you can unmute, and you need to tell me what is the difference between this and this. You can also put something in the chat if you want to. I will take a minute. I don't know if some of you have already attended this talk before. Maybe those people can refrain to answer, but I would encourage others to think and answer. What do they think is the difference between the speaker plus mic on the left hand side and the speaker plus mic or smart speakers which are connected to the internet? Anybody? I'm not seeing any answers. Am I audible?
Yes, sir.
Can somebody answer? Attempt to answer?
Sir, myself, Saida, sir.
Huh.
Yeah, sir, this is like first speaker is activator, I think so. And second one is a intelligent device, I think.
Right. Yeah, you're right. The basic difference here is that you have the speaker and mic. It may have some storage. You can ask it some questions and it can answer those questions. It can answer, but this is like this knows almost basically this are connected to internet, so they have all the answers what let's say what the internet has, right? Whatever the information is there in the on the internet, right? And especially with the chat GPT now, it can also kind of convert the information into knowledge. So basically it has the knowledge of the whole internet. So whatever is on the internet, it will basically know, which is much more than, let's say, what we generally know, right? Let's say few people. So it's like a all-knowing kind of a device now. Okay, you ask it anything and it will tell you. Okay, it can talk about art, it can talk about history, it can talk about geography, right? You ask any questions and it will know. So, so that is a very big difference. So, inherently, we will have very finite knowledge, right? But let's say internet, the knowledge on the internet, the information on the internet is vast, and these devices are connected to that vast information. That is what is very powerful. Okay, that is what why this becomes so powerful. Okay, and so another thing is that you will ask me what is the point in connecting a shoe to the internet, right? But the applications of IoT are amazing, and then they are only limited by the our imagination. So basically, if I start putting, let's say, this kind of different sensors, this is the actual example from the government website. You can, if you put GPS, vibrator, controller, power, camera, ultrasonic distance, and Bluetooth, then suddenly these shoes will help blind people navigate the city. Okay. So, and there are so many other uses you can have. So basically, why do we need IoT is because we want to add smartness to simple things, right? To be, and this is very powerful statement. To be smart, a thing doesn't need to have a super storage or a super computer inside of it. All a thing has to do is to connect to super storage or super computer. Okay, so basically a very tiny device, it might have very limited amount of memory, very limited amount of processing power, very limited amount of power. But let's say, especially if it is connected to a super computer, then it has access to super all the facilities of the supercomputer as well as storage, right? So computing and storage, then it can have almost like unlimited. So that is what is very powerful. So the connection is very powerful here. The connection to the of IoT. And it has several benefits to the consumers as well as companies. And it also, IoT devices will also generate a lot of data. Nowadays, we are seeing a surge in the AI ML applications in almost every domain. So who's going to generate this data, right? So IoT devices would be generating data in most of the cases. So I will talk about some use cases now. So, oh, sorry, yeah. So the applications, so there's a smart city, connected industry, smart buildings, autonomous cars, smart grid, health, agriculture, and many more. One more thing is you can see that the number of devices are exponentially growing, and already the number of devices are projected to be 10 times of human population. Okay, so human like almost 9 to 10 times of human population, which means that this is a huge market. Okay, so and therefore all the big and small companies are very interested to be part of IoT. Okay, so you can see Google, Microsoft, and many other top companies who are let's say looking this from the data perspective as well as a big market perspective. And then you also have a lot of startups, because IoT is providing a very nice opportunity for even a small team to come up with very interesting applications and create $1 billion companies. So this is the first application use case I wanted to show, and I hope that uh, the audio, I don't know, it's not very essential, but if it's nice if the audio is audible. Is it audible?
Yes, sir. Audible, sir.
Okay, thank you.
Excuse me, sir. Sorry to say, sir. Like audio not audible, sir. Please.
Okay, but I think it's okay. Audio is not important there.
Okay, sir. No issue.
Yeah, sorry. Yeah. So basically what this is basically about the application. Okay, it's still running. Okay, so the what is the application is? This application is, okay, this device is called as Nest, and this is basically a smart thermostat. Uh, just a minute. Huh? Yeah, sorry. So, but basically, this is Nest. Nest is a basically we have all seen the thermostats, right? So it's basically a thermostat. We know this from our ACs, right? We set a temperature and then this will maintain that temperature in the. So this is written in Fahrenheit. Generally, we use in India in Celsius. And the idea is that this in Western countries is used, thermostat is used for heating purposes and not for cooling. In India, we do it for cooling. And the idea is that uh, whenever, so this is a learning thermostat. This is not a normal thermostat, it's a learning thermostat. So what happens is that when you buy this device, install it in your home, and whenever you change the setting, it basically notices what time you are changing the settings, what time of the day and month and year. Okay, and then based on how many times you change at whatever instances you are changing, it will try to make some inference based on that you are not at home. Let's say from 8 to 5 you're not at home. During, let's say, 11 to 6 you will sleep, right? All those patterns it will automatically try to understand, and it will also try to understand at what times you are in which room and what are the temperatures you like. So basically it is learning what temperatures you like, and it builds a schedule around you. Okay, that's what is this device. pretty simple idea, not very complicated. And then, but you can see that this was founded by Apple engineers in 2010. That's the reason it's also very beautiful. But in few years, by Jan 2014, this was sold in $3.2 billion in cash, which is pretty huge. And around same time, Nokia was also sold, Nokia phone division, which Nokia was earlier a top company in let's say phone manufacturing, and it was almost around 25 years in the industry. And even so, the company was sold in very similar. Sorry, I need to. Okay, so basically in this, the Nokia also, which spent billions of dollars, had a big team, spent so many years, and still it was also sold in very similar amount to Microsoft. Okay, so that's what I'm just trying to tell you that IoT has the potential of building a billion-dollar company in using a small team, a nice idea, not very complicated idea in few years. Okay, so it has the potential. It has very good potential. Another example I want. These are my very favorite examples, and the very specific use cases. So this one is basically replenishment services. Anytime things are, let's say, things are over in our house, we can reorder, right? Like washing powder. Washing powder is over, then I can press a button and then order this kind of things. Okay, that's the basic
Don't
idea.
let running out ruin your rhythm. Introducing the Amazon Dash button for Prime members, a simple way to reorder the important things you always run low on so you'll never run out. Set it up to order what you want, then press it when you're running low. Get an order alert on your phone so it's easy to cancel if you change your mind. And with Prime shipping, you'll get new products delivered to your door before you run out and never miss a beat. Prime members, request your Amazon Dash button today.
Okay, so I hope that you understood what this is about, right? This application was about replenishment services, in the sense something, let's say washing powder and all, something you're out of the that particular thing, then if you press this button, and that will automatically order for you depending on what kind of settings you have done in your phone. So what this example simply, let's basically why this example is so important is that it is trying to tell you that the IoT application need not be complicated. This is a very simple application, right? Only one touch application. So you can also create this kind of very interesting, very simple applications with IoT. Okay, so IoT is also applications can be very simple. Okay. So then there are again very lot of applications in agriculture. I will not go into this too much. Then industrial IoT. So I'm just trying to whatever the applications I talked about till now were more like consumer IoT, where let's say the sensors need not be precise. For example, the temperature sensor in my house, if it has let's say resolution of plus minus 0.5. Generally, we have plus minus 1, right? Either it shows me 25 degrees or 26 degrees. So it's okay, 1 degree here and there. It doesn't matter much, in the sense that what will happen is that maybe I will use more energy or I will be slightly uncomfortable. But nobody's going to die, right? And there's not going to be huge, any kind of a big risk. So that is very important in the sense, in especially in case of industry, right? Industry, if machinery is not working properly, then the production can stop or people can die. So there, the risks are basically, the applications are very high risk, and we have to use precision sensors. Okay, that is the basic idea. In the industrial IoT, the focus is on productivity, safety, reliability, and that is the reason we have to use precision sensors, because the industrial applications are very high risk applications. So at this point, I generally ask the audience, what thing will you connect to the internet? Again, I would encourage you to please think about it and take 2 minutes, type in what you want. In the sense, can you please give example? What would you want to connect to internet?
Sir, basically our personal assistant devices.
Madam, I'm not able to hear you properly.
Sir, basically our personal assistant devices like mobile phones, laptops, desktops, etc.
Those are anyway connected to internet. Let's say,
Right.
what are the new things you want to connect to internet? Would you connect
Basically,
your would you connect your water bottle to internet? Would you connect your chair to the internet?
no sir, not yet.
Okay. Others?
Sir, we made all the participants to be muted, sir.
They can chat, they can write, basically they can write.
Sure, sir.
So I'm seeing one message from Mr. Professor Tyagarajan. So you're writing anything and everything, I agree, but can you pick some specific application? So let's say, just like somebody just said that it's not a good idea to connect a chair to the internet. So can anybody all of you think same, or some of you disagree that you can connect the chair to the internet? And what are the benefits? Let's say, what is the product you will create out of this? Okay. So can I know who was speaking before? Sorry.
Sir, this is Saichandar, sir.
Yeah. So one example is that we can connect basically a chair to the internet. One very good example, or I will say one very good application, let's say, is that uh, take an ex- take your car chair, okay, in the sense that the seat on the car, okay. So if you now put sensors on that seat, which will determine your posture, your weight, right? Then it can detect whether the person who's sitting is the owner or not of the car or not, right? And that can be, so even if a thief basically uh, tries to steal the car, it will not switch on the car because it is not able to detect. It can tell whether the person who is sitting is basically the owner or not, or at least permitted person. Okay, got the point? So another example is the attendance, right? So basically, if you have in the classroom so many benches and everything, and you have to take manually attendance, but let's say if I have, let's say, pressure sensors or pressure pads on the chairs, then basically we can automatically take attendance. We know because we know exactly who is sitting where. Okay, based on the profiles, posture, sitting postures, height, weight, and everything. Another example, let's say if you take is a pen, right? Or like, do you think it makes sense to connect a pen to the internet? Anybody? Yes, no? I hope you guys are there. I see 73 participants, but I don't see any participation.
Sir, I'll ask my system admin to make all unmute so that they can
Nee,
respond.
unmute. They can chat. I don't know. Like they should be able to type now.
Yes, sir.
Okay. Okay, you can ask the system admin to unmute everybody for the let's say for 5 minutes, next 5 minutes, and then we can mute everybody and we can then move on. So the question is that can I connect a pen to the internet? Is the question clear? Yes, yes. Assume that you are able to connect. Okay. The question is, does it make sense to connect a pen to the internet? What will you do with that? So technologically, you assume that it is possible. Keep in mind that Apple's pencils, right? They are digital. But question is, what will you do with that?
If pen writes on its own, we cannot. There is the iPad with the notepad. So we write, human interaction should be there to write the pen. But
Right.
connecting a pen, there is how it automatically writes it.
Okay, so
So
basically one very good example is that it can when you're writing, let's say you're noting down things, right? You're noting down things in your own handwriting. It is converting it into actual text, and it can correct for any mistakes. It can correct for any mistakes you have made. Sorry. Hello.
yes,
తను
possibility is there. Yeah,
I think somebody is speaking in between. It's not very clear. Like I think. Yeah, please go ahead.
yeah, it's the pen automatically it is going to correct the text.
Yes.
Will it do, sir? We have to write only the manual intervention is there.
Okay.
If the pen has a automatic writing,
Right.
of course, then we can connect to the Bluetooth. If
Right.
pen cannot, manual invention is there, it's very difficult even if you connect the Bluetooth device to any.
Okay. So one example I keep giving. So this is the whole exercise is to kind of tell you that the application of IoT is limited by our imagination. Okay. So one example I keep giving this example. I'm not trying to promote that, but the point I'm okay. One example I want to give is this. Let's say can be used by people to cheat, right?
Yeah.
Because the pen then can write in your handwriting the answers to the questions because it knows all the answers anyway. And it can write in your handwriting and it can also change using ChatGPT, right? Like each answer, let's say if I can sell it to 10 different students in the same class, all of them can write slightly different answers so that nobody can even basically uh, catch them that they are doing cheating. You got the point?
Yes, 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 yes.
So the point I'm trying to make is I'm not trying to promote cheating, but I'm trying to like convey here that if you think you'll get very interesting applications of even something like a pen, like chair, right? Right. If just like 10 minutes before when I asked, not nobody even thought of we can actually connect all these things to the internet, right? Like a water bottle also you can start connecting to internet to understand what kind of water you are drinking, how much water you're drinking, and are there any issues and what are the trends, right? So to monitor our health and all. So you can keep thinking of anything you find in your surrounding and try to think for 10-15 minutes. You will find very interesting, useful applications which are basically commercial. We can actually commercialize. Okay. So that's what I wanted to convey. Okay. So okay, then I will move then forward. Maybe you can mute the participants for the. Yeah, please mute the participants now. Thank you. So now let me talk about the research activities. What I'm like. So one example is what I have been working on is the IoT-based water monitoring. Can you please mute the participants?
R&D వాళ్ళు ఒక కోర్స్ ఇంట్రొడ్యూస్ చేశారు. రీసెర్చ్ పైన. సో దట్ ఇస్ త్రూ రీసెర్చ్ ఎలా చేస్తారు, ఎలా ప్రాబ్లమ్.
Somebody is talking.
ప్రాబ్లమ్ సొల్యూషన్ ఎలా చేయాలి, who are the end users, who are the users.
Hello.
Mute.
Nee, I think somebody is not muted. Okay. So basically, so the first one activity I want to talk about is the IoT-based water monitoring. So here we have done a lot of interesting work. So in Triple IT, we have a pretty decent like a decent campus of 66 acres, and we have the water coming from Manjira, and then we have a pipeline laid, and there are bore wells to supply also water to the additional water to the campus. And to monitor the water usage, what we have is that we have several analog water meters along the water distribution line. So all these pipes, the big pipes, which are going across Triple IT, which are almost from 2-inch to 4-inch diameters. And so what happens is that twice in a day, the plumber will go and collect, let's say, take image of the device and come back and note down, enter those values in the computer manually, and then basically store it in the database. So we wanted to digitize this thing. So what we did is our impression was that, okay, let's buy one digital water meter. Instead of, let's say, a normal water meter, let's buy a digital water meter. But that costed around almost 60 to 70,000 rupees. So to create a very low cost solution, what we did is that we came up with this IoT and machine learning based low cost retrofit mechanism. So what we did is, this is our main analog water meter. So we put different layers, and in that, this is the LED ring, then this is the camera, a Raspberry Pi camera, this is Raspberry Pi, and this is the power, okay? And this is a 3D enclosure. So basically, we are fitting everything inside this, and then fitting it on the top of the water meter. And then what we are doing is, we are taking the image of the dial, right? Dial has the value, and it conveys how much water has flown, okay, across that pipe. So we are taking the image of the dial, we are converting that image to number, okay? We are extracting that number and sending it to the, let's say, to the cloud, okay, through Wi-Fi. And so this is what we have created, and this was almost 1/10 of the cost of the digital water meter. If we so instead of buying, we came up with this very low cost version. And so this is a retrofit model. You can still use your analog water meter without any changes, without doing any plumbing or any other thing. And the machine learning, deep learning based algorithms will convert the images to the digits and send it to the server. And based on this design, we have filed patents now, design patents, utility patents, conference papers, journal papers, and we also won water challenge by Telangana state government. Okay. So is the idea clear? What we have done here?
Yes, sir.
Okay. So another very simple example. So keep in mind that all these applications are basically for issues which are pertaining to Indian conditions. So basically, these are Indian solutions to Indian problems. Okay. So so another example is that we have put accelerometer on the top of this tap, and based on how much you are rotating the tap, you can understand how much water you are using, and that value is being sent to this display. through Bluetooth. Okay. So, and even based on how much you lift it and move it, you can understand how much water you are. And again, we basically wrote a paper on that. Accuracy was very nice, and we published a patent papers, and this was also covered on a local news channel. Another thing is this learning water level meter. Okay, so just like we have water level meter, right? Ultrasonic sensors. If you put on in the tank, then you understand what is the water level in the tank, right? But just like you saw the Nest thermostat, the learning thermostat. So this is a learning water level sensor. Okay, so it can tell you what is your prediction. Basically, it can predict how much water you're going to use, what kind of devices you are, what kind of appliances you are using at what time of the day. And then it can also understand if your, let's say, tank has some issues, right? Another very interesting thing which we have done is that we are tried to replace the water flow meter, which is slightly expensive, with pressure sensors on a given pipe, because the trends are very similar. Okay, so you can make the pressure sensor learn the flow from, because keep in mind that we are measuring, we are taking values every 30 seconds. Okay, so because you are taking the data so very often, we can use a proxy sensor to tell what is the water flow meter. Okay, if you only collect data once in a day or something, then you can't tell at any time what is the value of flow. But if you, it's like here, because we are taking values every 30 seconds, then we can apply machine learning and then basically estimate what is the flow from the pressure sensors. Okay, because pressure sensors, even for a very big pipes, the pressure sensors are still the same. They're very, very cheap. But as the pipe dimension increases, the water meters will become very, very costly. Okay. Then another thing is that the rainwater project like a pretty famous. It's an NGO here which is working on the rainwater issues, like rainwater harvesting in Hyderabad, and they came up with the problem statement of understanding what is the current underground water level. Okay, so basically we came up with this borewell monitoring device, IoT based borewell monitoring device, which is basically there's a floating bob, and then there's a string, and then there's a pressure sensor here. So based, whenever the bob is floating, the pressure, there's a high pressure on the sensor, basically sensor, and whenever the bob is floating on the water, the pressure reduces. Okay, because the string is then slack. So based on that, we can measure how much the depth of the or what is the water level. Okay. So this again we came up and then we patented this. We basically, and we also published a paper, and some of them we are now deployed in Rashtrapati Nilayam in Hyderabad. We also created some dashboard for the same. And like using these devices, we also have one startup, Hydroverse. We are trying to commercialize these products now. And we have created some apps and pretty maintain. And keep in mind that this has been pretty fruitful, I will say, topic for us. Already a lot of, like, 2 people have graduated, a lot of people are submitting their thesis now soon. We have written journals, conferences, patents, utility patents, and a huge data set. Okay, so basically we have been collecting our own huge data set. We have won national, international level hackathons. And we have been mentoring other colleges also to building this kind of prototypes. So this is the praise we got from KTR Garu regarding that retrofit device. Given that you're not able to listen to the video, I will skip this, but you can see the YouTube link is given anyway.
Compliment the guys who are working on this.
Then let me talk about the remote labs, the second application. Okay. So till now, I have talked a lot in previous presentations on air pollution. So in this one, I'm not talking about air pollution at all. So I'm focusing more on new ideas which we have done. So okay. So the idea behind remote labs is that all our physics, chemistry experiments in the school, right? So we don't have any access. We couldn't have any access during COVID, and also if you go to rural schools, not every school will have setups. Okay, so it's not possible. So what we have done is that we have created retrofit. We retrofitted the experiments with sensors and actuators, so that anybody from anywhere in the world can access the setups through a browser. Okay, basically using any simple smartphone, they can basically have access to this lab setups from anywhere in the world 24/7. That's what the idea is. So take an example of this focal length experiment, right? So this focal length experiment, there's a lens, and then you have a object, and then it creates an image, right? So basically, depending on, and you keep moving the image and the object such that the image is very sharp, like it's pretty clear image, okay? And at those distances, you will try to find basically those values of u and v. You will be able to find what is the focal length of that lens, right? So this is the setup which we created, okay, and then retrofitted with the so you can see this setup, and we retrofitted it with the motors, so that we can move them, and then there's a camera, okay, and then which you can easily access through, let's say, this kind of a web-based web page. And you can see that we have created several. Right now, they're not online. No, it needs some maintenance. So we also worked on chemistry experiments like titration, electronics experiments like Kirchhoff's voltage law, vanishing rod, conservation of mechanical energy, and we have written also papers on them. So again, this is just a dashboard preview of the same. And recently in the IMC, our team won the third All India, basically, they got a third All India rank in this 5G use case, and they got a best demo award in 2022. Again, we have basically one journal is accepted now, and 3 international conferences are published. Few MSCCs already are going, people are working on this. So it has been pretty successful. And then let me talk quickly regarding the living lab activity at IIIT, which is very popular, and a lot of dignitaries have praised regarding this initiative of Smart City Living Lab at IIIT. I would also invite you to see this. Okay, so this is a kind of a this is a multidisciplinary initiative by a lot of people. Lot of people coming from different centers, and you can see people coming from software engineering backgrounds, signal processing like communication background like me, then hardware background, computer systems, building sciences, special informatics, our Center for Innovation and Entrepreneurship and Technology Transfer Office. So the involvement of the CIE and TTO is also to create products out of this, and also commercialize the solutions which we are creating. Okay, and so these are the people who are involved. Ramesh is from software background, software engineering background. Vishal is from building sciences. Aftab is from hardware. Deepak is from computer systems group. Prakash is TTO, and Anuradha is our lead architect. Oh, sorry, this, and Karthik is from Software Engineering Research Center. So these are the different applications which are which we have already started working on, and smart room, solar power supply, crowd monitoring, water distribution, street light, air quality, weather. One very important thing when I want to what I want to also convey is that the whole of campus is the living lab. It's not one lab here, but it's the whole of campus. So we have deployed, just like I mentioned, the water meter, right? The smart water meter, the retrofit meter. We already deployed 12, 15 places. Already we have deployed since last 2, 3 years. They have been running. And even on the overhead tanks, we have deployed water level sensors and all. So the good thing about IIIT is that, again, as I mentioned, it is very nice campus, 66 acres with 100 faculty, 2,000 students. many research centers, and the idea is that there is a 4,000 floating population. So why we call this as a living lab is that we are deploying things on actual living conditions. So we are working on street lights, which people are actually using. One more very important distinction from other, let's say, labs in other places is that this living lab is open to others for experimentation based on mutual understanding. Okay, so basically, basically the startups can come or companies can come and deploy their solutions here, test them out. Okay, so that's possible. So we are open to that. And the idea is that this is a test bed for smart city deployment, and we want to promote startups. We want to do research in smart city, and our focus is on creating local solutions for local problems. So all the solutions which you have seen are very India centric, and we want to create huge amount of data set so that we can do AI/ML modeling for Indian scenarios. And this is a place for collaboration between different stakeholders. You can see that different government agencies are part of it, different corporate partners are there, startups are there, think tanks are there, knowledge partners are there. These are the themes which we have started the Living Lab with. So it has been almost now 4 years we had started the Living Lab. And more than 300 nodes are deployed in the campus over different themes or different applications. And, and everything is based on 1M2M. 1M2M is an interoperability standard. So basically, so that the data can be easily accessed between different applications, and they can understand basically application can understand the other application. A lot of very interesting, useful dashboards have been created now. So this is a summary view. This can show all the nodes deployed as well as some parameters which are being monitored. And then this is a 3D view. This is a live view, and then this is a what is it called, a 2D view. Then we also created this Grace, which is a gamification of exploring the data inside the campus. And okay, then we have created an app for this. We have created the dashboard for node maintenance. And as I mentioned, we are also working with our corporate partners. So with Silicon Labs, we have done an excellent job of deploying Wi-Fi-based devices for smart street lighting, and that too we have done in 3 phases. We're also working with Qualcomm on the HGI part, and obviously ZF gives this Yamuna Power Limited, Saint Gobain, Intel. As I mentioned, with Bison, we have been having a very big success story where, along with Silicon Labs, we had deployed the Bison based solution for street lighting in 3 phases in Triple IT. So almost 70 poles have been with this Bison based street lighting. And we are also working on the city IoT operating platform so that we can give solution for the smart cities. Indian smart city. So this is the city operating platform which Triple IT has developed. And then we also have the 5G based 5G use case lab now, which we have planned several very interesting use cases. And we also have water COE from the Hyderabad Water Board. And the idea is to work on NRW modeling analysis, water quality, and digital twin for STP. And Intel, we are working. And then we had a lot of publications, a lot of patents, as I mentioned earlier. And one thing before I end, I wanted to also highlight some very interesting thing is the kind of courses we are doing at IoT, courses we are doing at Triple IT. So we have courses for civil, MTech civil people. This is like a computer-aided structural engineering. And then our CSE for CSE, the IoT course is core course. So they do introduction to IoT in first year and then embedded system workshop in the second year. And for our EC students, communications controls. And then we also offered once this talent sprint course for professionals. So the unique feature of this course is that they are generally very project heavy and open-ended. So we do not define any specific, we give the problem statement, but we never define that if you do this much, the problem is over. We keep asking the students to do more on this because we give problem statements where we don't know what the answers are, the solutions are. Okay, and this some of them have resulted into patents and publication, and our students have won, the course grades have won international hackathons as well. So you can see that they do lot of activities. Generally, what happens is that the any project in let's say ECE will end up on a breadboard. But here we start with that, then we go to normal zero PCB, then we ask them to design a PCB, and then we also ask them to design an enclosure, deploy things, collect data, do analysis. Okay, so that's what we generally try to push our students, and this is one project which had won an international level hackathon. They had deployed some air pollution sensor in my kitchen, and they had done some very interesting analysis on that. And in the campus also, we have now deployed almost 12 nodes after the doing the course. And these are the CSE people who have done, let's say, who are doing all the soldering, debugging of electronics and all, which is very interesting because not many CSE students will be able to do all this, or they will not get a chance. That's what I'm trying to say. And then not only that, but analysis of the data. We also have this very interesting course called as College Research Affiliate Program. And so the idea there is that we have 3 stages in that. Then the first stage, the student will do 1 month online teaser. Generally, 300 students will come out of almost 5 to 6 colleges, and then we will have a 2-day hands-on in-person workshop where we will basically make them create a solution for a particular problem. And then out of that, they will come to Triple ID for a few months of internship. So we also have this faculty immersion, but it has not been that successful. People didn't get any time. Faculty are not getting any time. But we wanted to guide some faculty on doing some projects for a few months. And KGDT was part of the first. And you can see that the 3 things have happened, and it has been pretty successful. I will say some of the people have basically some students from some colleges have got patents granted based on the work with us, and then research papers have come out. Few faculty have visited Triple IT based on this, and then they have written papers with us, journals with us, and some collaborative research proposals have also been submitted. And a lot of students have converted. The students who came here for doing a long-term internship have converted to masters at Triple IT. And with one of the the intern who came had a startup incubated, and another I'm in a discussion with. So it has been pretty successful, I will say. And with this, I would like to end my presentation, and thank you very much for your time, attention here. If you have any questions, I would be happy to answer.
So, sir, I'm requesting the participants, if you have any query, can ask the sir.
Yeah. So generally, this presentation will take 1.5 hours because it's very interactive. But online, I think it's not working that well. The interaction part is not working that well. Otherwise, this easily takes 1.5 hours. Yeah, please ask questions. Yeah.
Excuse me, sir.
Yes.
As you mentioned in your presentation that there are some outsiders also can come and utilize that provisions provided by IT. If any of our MTech students or UG students want to have innovative ideas based on this
Right. So
IoT.
they have to give a proposal, what they will do, how they will do, and then what are the impacts. So we can try, we can look at it, and then we can decide to deploy.
Okay, so do we need, how should we approach, sir? What is the
You can write a proposal but it has to be, please make sure that these are the test bed for actual deployment. So it has to be, the application has to be of that level. I'm saying
Okay.
maybe they can try few basic thing testing at your college and then come to us for an actual deployment, large scale deployment or whatever. So these
Okay,
are basically, it's like before going to the city level, you are coming to a campus level. That's what we are trying. I'm trying to say. And our complete campus has Wi-Fi, LoRa, Wi-Sun. Okay. So
Okay.
coverage is there. So we can provide you with that kind of access.
Okay, sir. Thank you.
Thank you.
Hello, sir.
Yes. Please.
This water level sensor, can you afford ordinary person, sir?
Sorry, what?
Water level sensors.
Uh-huh. Yes, what is the
Hello,
question? Yeah. What is
I'm
the
audible
question?
to you, sir.
Yes, it's you're audible.
Suppose so many buildings are there in Hyderabad. Suppose one house owner can build. How much is the cost this water level sensor, sir?
You're asking about the product, or are you asking about that? Can you make it?
This water level sensor you mentioned,
Yes,
sir.
yes, it will hardly cost 10,000 rupees. 10,000.
10,000 rupees. Okay, sir. Okay.
Any more questions from the participants? Right. Thank you, Sachin sir. Now I request our head of the department, Dr. Angoti Saida sir, to give the uh, thanks to our today's guest research person, Sachin Chowdhury sir.
Yeah,
Sir Saida sir?
yes, Sai sir. Am I audible, sir, Sai sir?
Yes, sir, you are audible.
Yeah, respected Sachin Chaudhary sir. On behalf of our team, entire team, I extend my heartfelt thanks for your enlightening session on Internet of Things, introduction and applications. During the national level faculty development program on innovative approaches in IoT and embedded system, hands-on approaches to bridging the theory and practice held on today. Sir, here your deep insights and practical knowledge provided the immense value to participants, bridging the gap between theory and applications in IoT. The interactive elements and real-world examples you shared and captivated the audience and inspired many to explore innovative approaches in their teaching and research endeavors. We are truly grateful for the time and effort you dedicated to making this session a resounding success. Your contribution has left the lasting impact on the participants and enriched the overall quality of the FDP. Thank you, sir, once again for your support and expertise. We look forward to collaborating with you in the future for such impactful initiatives. So, thank you,
Thank
Sachin,
you, sir.
sir.
Thank you very much.
Yeah,
Thank
yeah.
you.
Thank you, sir. Thank you, sir.
Thank
Sai,
you,
sir.
sir.
So
Thank you.
this is from today. We can end the session
Thank
today.
you,
So share the feedback link and attendance link. Possible also quiz for all the participants.
sir.
Participants are like I'm requesting you all. These are the interactive sessions. So as Sachin sir mentioned today, ask much more queries so that it can be goes on in well manner. Okay, so from tomorrow onwards, we're expecting more number of questions so that it could be good, interactive, and impressive. That's all from my end, Sai sir. You can continue.
Right. Thank you. Thank you all the participants for your presence and participating in the activity. Right. Thank you one and all.